All right, so you're interested in machine learning. And I mean really interested. Not just using the tools, but understanding how they're built from the ground up. If that's you, then you've come to the right place. Today, we're laying out the roadmap, a serious academic path to one of the deepest, most fundamental topics out there, measure-theoretic probability.
Okay, let's get one thing straight right out of the gate. This whole journey has a barrier to entry, and as the slide says, it is absolutely non-negotiable. You have to be comfortable with proofs. I'm not talking about plugging numbers into a formula. I'm talking about building logical arguments from scratch. It's a different way of thinking, and it's essential. So here's our game plan. We'll start with how to think like a mathematician. Then we'll cover the core undergraduate stuff you'll need. After that, we hit a big fork in the road. From there, it's into what I call the analysis gauntlet, and then the final climb to master rigorous probability. And at the end, we'll talk about why this climb is so worth it.
Right, let's kick things off with milestone 0. Before we touch a single derivative or matrix, we have to learn the language. We have to learn how to think, write, and argue like a mathematician. This is the bedrock. Everything else we're going to talk about is built right on top of this.
The best tool for the job, hands down, is Velleman's How to Prove It. This book is fantastic, especially if you're studying on your own. It's clear, it's to the point, and the secret weapon? It has solutions in the back. That feedback loop is absolutely critical when you're starting out. It's how you know you're actually getting it right.
Okay, once you've got a solid handle on proofs, the real journey can begin. And it starts with 2 foundational pillars of undergraduate mathematics. You kind of learn these at the same time, and you absolutely need both of them to understand any of the advanced stuff later on. And those 2 pillars are linear algebra and what's called introductory analysis, or sometimes real analysis. Think of it like this. Linear algebra gives you the entire language of vectors, spaces, and transformations. And analysis, well, that gives you the rigorous tools to deal with things like limits, infinity, all the tricky stuff. You need to master both, period.
Now, for textbooks, we need to be smart. For linear algebra, Friedberg, Insel, and Spence is a fantastic choice because it perfectly balances theory and application. And for analysis, you really can't beat Abbott's understanding analysis. It's just brilliant at building the intuition you're going to need when things get way more abstract down the line.
So after you've conquered those fundamentals, you get to a fork in the road. And this is a really important moment. You have to ask yourself, what is my goal? Am I trying to be an amazing data scientist who applies models effectively? Or am I trying to understand the deep theories so I can invent new methods? The applied path, which is a great path, by the way, takes you towards mastering linear models with books like Kuttner. But the theoretical path, the one we're following today, that one leads up a much steeper mountain. It goes through some heavy-duty analysis to get to that true, measure-theoretic understanding of probability. This is the path for the future researcher.
So you chose the theoretical path. Awesome. Welcome to the analysis gauntlet. This is a sequence of tough but rewarding books, and their whole purpose is to build the intellectual engine you need to really handle measure theory. The first milestone in this gauntlet takes all that great intuition you built up from Abbott's book and cranks the rigor up to a whole new level. Seriously.
And that means it's time for Walter Rudin's Principles of Mathematical Analysis, or, as it's famously known, Baby Rudin. This book is legendary. It's tough, it's elegant, and it has a reputation for forging real mathematical maturity. It's a rite of passage. Now listen closely. This part is really important. You do not need the whole book. Your goal is to master the first 7 chapters. That's it. They have everything you need for the next stage. So the advice is simple but crucial. Ignore the rest of the book. Okay, after Rudin, we're ready for our next milestone. We're going to take our first step into the world of functional analysis, which is kind of like linear algebra on infinite dimensional spaces. But we're going to be really strategic about how we do it. We're going to use Kreyszig's introductory functional analysis. And the reason for this specific choice is brilliant. It teaches you functional analysis without assuming you already know measure theory. This lets you tackle the new, abstract ideas on their own first, before we add another huge layer of complexity. It's about taking smart, manageable baby steps. All right, with that incredibly solid foundation in analysis now in place, we are finally ready. We've done the prep work. It's time to climb the actual mountain. This is where we take on measure theory head-on and use it to finally understand probability with true rigor. This final climb has 3 clear steps. First, we learn measure theory itself.
Second, we get a nice, gentle introduction to how it's actually used in probability. And third, we go for the whole shebang, the full, comprehensive, graduate-level treatment that ties it all together.
For the foundation, step 1, our main text is Schilling's Measures, Integrals, and Martingales. This is your proper, formal, no-nonsense introduction to the subject.
And here's why this book is such a perfect choice, especially for self-study. It's not just that it's thorough and has great proofs. The author provides a complete solution manual for free on his website. I mean, for anyone learning this stuff on their own, that is an absolute game changer. It's an invaluable resource. Next up, we use Rosenthal's A First Look at Rigorous Probability Theory to bridge the gap. Think of this as your training ground. It's a shorter book, it's very problem-focused, and its whole job is to get you comfortable using all that abstract machinery from measure theory on actual probability problems. And that brings us to the final book, the capstone of this whole journey, Probability and Measure Theory by Ash and Dolians-Dade. This is it. This is the full graduate-level understanding we've been working towards.
Now, you might be thinking, hey, why not the super famous classic by Billingsley? And the answer is purely practical. This book by Ash covers basically all the same material, but it has a ton of solutions in the back. Again, for a self-studier, that is gold. Once you get through this book, you've done it. You'll have that rigorous understanding of probability you set out to get.
So, after all that, why? Why go through this incredibly difficult intellectual climb? Because once you get to the top, the view is just completely different. You can read and actually understand cutting-edge research papers. You have the tools, the deep down, in-the-gears knowledge to create completely new machine learning methods yourself. You see, you no longer look at probability as just a collection of formulas to memorize. You see it as a language with its own deep, elegant grammar. And so the question for you isn't just about what you can understand anymore. It's about what you can create. You've learned the grammar. Now, what will you write?